Year 9, let's take up Checkpoint 2017, Paper 2. This is a calculator paper, so you are allowed a calculator, but always try and do mental calculations when you can, and double check yourself with a calculator. All right, let's get started. Writing algebraic expressions. So here we've got a question where they're talking about the cost per square meter of a carpet, and there's also a delivery charge of $21, which is on top of the original cost of the carpet. So if Peter buys n square meters of the carpet, we're going to then say that if this is $15 per square meter, it's $15 per n. And that means 15 times n, right? Because if n is 1 square meter, I do 15 times 1. If n was 2 square meters, I do 15 times 2. So I'm going to do, that's 15 times n, which means 15n. Now looking over here, it could be this answer here, or it could be this one here, because that could multiply through and be 15 times n and then 15 times the 21. So let's watch the rest of this and figure out what we need to do with this 21. The total delivery charge is 21. So it doesn't matter how much carpet you're getting delivered, it costs 21 more. So also a $21 delivery charge, that would be plus a $21 delivery charge. So that's 15n plus 21. Okay, so that is this one down here. All right, so this is our answer. Next question. Sharing by ratios. Now this doesn't surprise me because we haven't really done too much of ratios just yet, so let's go through this now. Hopefully you'll understand it, and we will try to get through some more ratio practice later. Right, so Andy, Brian, and Charlie have to share $72 in this ratio. How much does Brian receive? Now first of all, we're not doing 72 divided by 3. Andy is getting 2 shares, Brian is getting 3 shares, and Charlie is getting 4 shares. So they're not sharing it evenly. They're sharing it out based on this proportion. So what we should look at first is how many shares are there all together? Not 3 shares, remember, because Andy's getting 2 shares, Brian's getting 3 shares, and Charlie's getting 4 shares. All together, that's 2 plus 3 plus 4. That's 9 parts. I'm going to split the $72 into 9 parts and share it out in this proportion. Okay? So how much would that be per part? If I'm going to split the 72 into 9 parts, I'll do 72 divided by 9, that's $8 per part. And step 3, how much does each of them get? Well, this is where I really should have started by saying, what does this ratio mean? This ratio means that Andy, Brian, and Charlie, in the same order as it's given in the question, will get 2 parts, 3 parts, and 4 parts respectively. If ever you've seen a question the word respectively, that means based on what you've just read in the same order. So Andy is respective to 2 parts, Brian is respective to 3 parts, and Charlie is respective to 4 parts. Now I've already multiplied this ratio out times 8 because we said that it would be $8 per part. So 2 times 8, 3 times 8, 4 times 8. That's going to be 16 for Andy, 24 for Brian, and 32 for Charlie. Step 4, you should always reread the question at the end to make sure that you've answered it completely and you know exactly what they're asking for. Remember, they're not asking me what is the ratio. They're not asking me how much Andy gets. They're asking how much does Brian receive. And Brian should get $24. That's this guy in the middle here. So it's important that you know that this ratio relates to the names in the order that you see them. So our answer is $24. Okay, next question. Graphed simultaneous equations. Now I hope we don't have problems with graphing lines, but they've given us one line already. They've given the line with the equation 2x plus y equals 12. And they're asking us to graph a different equation, so not the same one as you see above. Completing the table of values, we need to graph that. So if we're going to graph the line y equals 2x plus 2, in my table of values, I see they've already given us the answer if x is equal to 0. And if x were equal to 0, it would be 2 times 0, which is 0 plus 2. That gives us 2. They gave us the answer to start us out, but they're asking us to fill in the answers for if x is 2, if x is 4, and if x is 6. So I'm going to do my working over here. If x is equal to 2, I'll substitute 2 into the equation above. Instead of x, I put a 2, so it's going to be 2 times 2 plus the 2, and that's going to be 4 plus the 2, which is 6. So when x is equal to 2, y is equal to 6. That's the coordinate 2, 6. So over here, 2, and then up to 6, that would be this point here. Okay. Next, if x were equal to 4, same equation, same rule, y is equal to 2 times x plus 2. So if x is equal to 4, I'm going to replace this x with a 4, and that gives me 2 4s plus 2. That's 8 plus 2, which is 10. Okay, so when x is equal to 4, y is equal to 10. If I show you on the graph here, this would be the point 4 and up to 10. That would be the point right here, right? And I'll just fill that into my table of values when x is equal to 4, y is equal to 10. Next, our last point in our table of values is when x is equal to 6. So if x is equal to 6, I replace the x with a 6 here. That would be y equals 2 times 6 plus 2. 2 times 6 is 12, so that's 12 plus 2. And 12 plus 2 is 14, so y equals 14. So another point on this line will be where x is equal to 6 and y is equal to 14. That is going across to 6 and up to 14. That's this point up here. Okay, let me just fill that into my table of values. When x is 6, y is 14. And I can go ahead and graph that line. You see my line goes through the points 0, 2, 2, 6, 4, 10, and 6, 14. Okay, now that I've graphed that line, write the solution to the simultaneous equation. You don't need to do all this algebraic working down here. You've got this line graphed for you already. 2x plus y equals 12 is this one here. And y equals 2x plus 2 is this blue one that I just done here. And the solution to the simultaneous equation is the point, the x and y point. So that's why we've got an x and y answer, the xy coordinate that is on both lines at the same time. And that is right here, which makes me happy. It's easy to find, it's nice and easy to see. It's a bit tricky because it's between 2 and 3, but I would hope you would know that right between 2 and 3 is 2.5. And it's between the 8 and the 6. That is a bit tricky, but right in between 8 and 6 should be 7. The scale they chose there wasn't the easiest for us, but that should be 7. So x is equal to 2.5 and y should be equal to 7. Okay? Next question. Interior and exterior angles of polygons. So this is a polygon. More specifically, it's a pentagon. It's got 5 sides. But any polygon, any closed, straight-edged shape should follow these rules. And the exterior angle is a lot easier to deal with than the interior angle. So we're going to start with that one. Exterior angles of a polygon, they haven't been drawn on here. None of the exterior angles have been drawn. I've just got this one interior angle drawn. So I'll go ahead and draw this on here. That's just extending this line out, so making a straight line here, and that is important that it's a straight line. It's not going down at some weird angle here where it's not a straight line. Okay, it's a straight line, a continuation of one of the sides. And that makes a straight line with the interior angle. The exterior angle is this angle over here, right? Not this 180 degrees here. Because of course, yes, I did draw a straight line, but I'm interested in the other side of the straight line. The exterior angle is the angle that adds with the interior angle to make 180 degrees. So I'm going to say that there then. This is my rule about exterior and interior angles. An exterior angle and an interior angle adds up to 180 degrees because I have to draw a straight line to make it. Right? I know what the interior angle is, so I'm going to work out what the exterior angle is. The exterior angle plus the interior angle, which is 118, must equal to 180. If I rearrange that, I'll see that the exterior angle must be equal to 180 minus the 118, because it was plus on the other side, now it's minus. So the exterior angle must be 62. I should always label my working on here to help me with any further work that I'm going to do. So this is 62 here. Right, now this isn't quite answering my question just yet. I'm being asked, how can I tell from the size of the angle on the pentagon that it's not regular? That means that this angle, this angle, this angle, this angle, and this angle, they're not all the same. Regular polygons have all sides the same and all angles the same. Now it's not drawn to scale, so we can't just guess at it. We've just worked out the exterior angle because that means we're going to use our exterior angle sum rule, which is a lot easier than the interior angle sum rule. The exterior angle sum rule I can show you like this, is if I add up all of the exterior angles, so this is 62, I drew another straight line out here, and I don't know what this is, but if it was a regular polygon, it would also be 62. I'll draw another straight line out. Oops, it's gone a little bit crooked here, but it's meant to be a straight line out here. This would be the next exterior angle. And then I've got another exterior angle over here and another exterior angle over here. So those are all 5 of the exterior angles. And if this is a regular polygon, they should all be the same size. Now, the interesting rule about the exterior angle sum is it doesn't matter what kind of polygon this is. It could be a rectangle, a pentagon, a hexagon, an octagon, any kind of polygon, and the exterior angles will add up to 62 plus whatever this is, plus whatever this is, plus whatever this is, plus whatever this is. I'm facing the same direction that I started in. That should be 360 degrees. Let's go through that again. So if I start facing out in the direction as the red line's pointing, and then I turn this angle here, I'm facing this way. I turn this angle here, and I'm facing off in this direction. I turn that angle there, this direction, that angle there, and then this direction, that angle there. I've made a full turn. So the exterior angle sum for any polygon is always 360 degrees. That's why I wanted to work out what this exterior angle is. It'll make this easier for me. So I know that these all need to add up to 360. Now, will the exterior angles all be the same? If I've got 5 exterior angles here and they need to add up to 360, I would do 360 divided by 5, and that's 72. So no, they won't all be the same because I already know this one is 62. So they can't all be 62. If they were all 62, that doesn't make 360. So no, this is not a regular pentagon. All right, next question. Kieran buys a car for $8,000, and the following year he sells it for $7,500. Find the percentage loss. Now I've put this under the heading percent profit, percent loss, or percent change, because a percent profit or loss is the same thing as some change in the value, whether it's gone up or down. Okay, so percent change is always written as a amount of change in a fraction over the original value times 100, because to turn a fraction into a percentage we times by 100. Now, important thing to notice that it's the original value that's at the bottom here. The most common mistake people make is they accidentally put the amount of change over the new value. Now, looking over here, he buys the car for this value. That's the original value, so that's the value that goes on the bottom. And the following year he sells it for this value. We don't put that on the top. We find the amount that this value has changed. Okay, so another way of saying change is it's the new value minus, or the old value minus the new value, or the new value minus the old value. Whichever way is going to make this positive, because we want to make a positive percent change. Okay, so I'm doing the original value, which was the bigger value, minus the new value, which is the smaller value. So that's going to be 8,000 minus the 7,500 over the original value. And always remember to think carefully before you write this fraction. The original value goes on the bottom. That works out to be 500 over 8,000 times 100. Oops, that's twice. And that works out to be 6.25%. So our answer is 6.25%. He has lost 6.25% of the original value when he sells the car. Okay, next question. Okay, trial and improvement. And I know we've been through questions like this in the homework, and I know it takes a lot of work. You need to think carefully before you go trying random numbers. You need to see, what was the result last time? Was it too high? Was it too low? What should I try next? So they've started us out here saying that we should start with the number 7, and we're looking for an answer correct to 1 decimal place of a value that would make this equal 400. So starting with the value of 7. If x equals 7, just like when we were substituting into our line, I'm going to replace the x with 7. I'm going to work out what that's going to be. So 7 cubed plus 5 times 7, that's 343 plus 35, right? Because that was 7 cubed, and that's 5 times 7. That's 378. And I'm trying to make 400 here, right? We're trying to find out what x value makes this equal to 400, and it's not 7, because that's too low. Okay, so we're going to go on, and we're going to try a higher number now. How about 8? Excuse me. If I try 8, replace value of x with 8. I'm going to cube it. I'm going to add 5 times 8, and that makes 512 plus 40. That's 552. Now that's too high. So I tried 8, it's 552, that's too big. Let's try something between these two numbers. How about 7.5, right in the middle? Right, so 7.5 cubed plus 5 times 7.5, that makes 421.8575 plus 37.5. Okay, that worked out to be too big again. So it is closer though. It's bigger than this one, it's smaller than that one, it is right in between, but it's not good enough. It's still too big. So I now need to try something smaller than 7.5. How about 7.2? I've gone a bit lower this time to see if that's going to help. Now 7.2 cubed plus 5 times 7.2, that gives me 373.248 plus 36. Now that together makes 409. I'm getting much closer, but it is still too big. So don't give up, keep trying. Look, we're getting closer and closer. Let's try something a bit smaller than 7.2, but definitely still bigger than 7. So 7.1. Now when I put 7.1 as this, 7.1 cubed plus 5 times 7.1, that gives me 357.911 plus 35.5, which makes 393.411. That looks really good. It's getting really, really close now. Now this is too small and this is too big. I still have to try one more thing because I don't know which one's better. I could guess, but I don't want to guess. I really want to be sure. I'm going to try the value right in between. Even though my answer only needs to be to one decimal place, if I try the number right in between this, I'll be sure that I've got the right answer to one decimal place, 7.2 or 7.1. So last number to try the number right in between, 7.15. So 7.15 cubed plus 5 times 7.15 makes 401.276. That is too big. Now what that tells me then is that x must be smaller than 7.15. So maybe it's 7.14, maybe it's 7.13, maybe 7.12. I don't know exactly what it is, but it's less than 7.15. Why that's interesting to me though is because if it's less than 7.1 with a 5 next to it, it does not round up to 7.2. That will still be too big. So it's going to be something smaller than halfway, so it rounds down to 7.1. So my answer, x must be 7.1 to one decimal place. I know it's not the exact answer, but it is the correct answer to one decimal place, as close as we're going to get. Next question. Write the area of a circle and setting up and solving equations. Because in this equation, we're told that a circular fish pond has this area. So let's just sketch that. Here's a circle. What we want to calculate is the diameter of the fish pond. Let me just show you that. That's the diameter from one side of the circle all the way across to the other side of the circle. Right. One thing you may or may not know is that the area of a circle is calculated by doing pi times the radius squared. Now, pi is a number on your calculator. You can go looking for it. Look for that symbol. If you push that button, you'll get a number that's really long, but it's not a recurring decimal, and it doesn't seem to have any sort of pattern in its digits. It starts with 3.1415 and goes on forever. You don't need to know what that number is. You just need to know how to find it on your calculator and use it. Remember, this is a calculator paper, so you're supposed to use your calculator. Okay, now a lot of people think that because I'm given the area, I don't need to use the area formula. That's absolutely the opposite of what you should be thinking. If you're given the area and you need to set up and solve an equation, you need to use this formula because you can say that this is equal to 20, and that's your equation. So I've got an equation 20 equals pi r squared because the area of the circle is 20 meters squared, and that's the formula that we use to get it. Now, pi is just a number, so don't think that there's too many things you don't know here. We'll just treat it like a number, we'll use it on our calculator, and we'll calculate it. So I want to get r on its own. I'll take the pi to the other side, and I'll divide. Okay, so I've got 20 over pi is equal to r squared still. I need to get the r on its own, so I'll work out the 20 divided by pi, and that's been rounded, by the way, and I will square root it to get the r on its own. So the square root of r must be approximately 2.52. And to work out what the diameter is, I should see from my diagram here, the diameter goes all the way across the circle, whereas the radius would just go from the center out to the side. So the diameter is 2 radiuses, or 2 radii. D is equal to 2r. If r was this up here, then D would be equal to 2 times this, which is 5.05. Now I know what you're thinking. You're thinking 2.52 times 2 does not make 5.05. That would be 5.04. But that's because I've rounded this answer here. Here I'm using a more accurate value. Okay, so the diameter is 5.05. Next, Pythagoras. Okay, we've got this trapezium and it's made up of triangles. We're told some of the lengths of the triangle, and it's really important that you read through this, even though it's very wordy and it's got all these letters. It's important that you understand what it means. Most of it's already shown on the diagram, but some of it's not. ABE and BCE are right angles, and you see that they've got that ABE and BCE are right angle triangles. So these two triangles are right angle triangles. Triangle CDE and BCE are isosceles triangle. So this is an isosceles triangle and this is an isosceles triangle. And we can see that from the markings. These two sides are the same for the BCE triangle, and these two sides are the same for the DEC triangle, or CDE triangle. Okay, and they tell us that also in writing. AE equals 3 centimeters. There's something they didn't tell us in the diagram. AE is this side here, is 3 centimeters. And EB, so that's this here, is 4 centimeters. So let's go ahead and label that on there. Now I took the liberty of saying this is 3 and this is 4, just as they told us, but because the marking says that these two sides are the same, this is also 4. Okay, I want to work out what the length AD is. AD is from here all the way across to there. Now I know that this much is 3, but I don't know what that is. And I don't have any way of finding it either. I don't know what this length is, and I don't know what that length is. However, if I knew what this length was, this is the same length as it. So let's work out this length here. In this right angle triangle here, this side length squared plus this side length squared is equal to the longest side, called the hypotenuse side, squared. Okay? So I'm going to go ahead and work out what that green line there between E and C is. I'll call that line EC. And I'm using Pythagoras' rule, saying that EB squared, which is this length here, squared, plus BC squared, which is this length here, squared, is equal to EC squared. That length in green, squared. Okay, I know using two letters is confusing, so I'm going to switch this now for their values. I'm going to say that EB is 4, BC is 4, and EC, I'm just going to use a single variable for that. I'm going to say that C, because in my Pythagoras theorem, it's this last one here, that's going to be C. So let's let C be EC, and I can say that 4 squared plus 4 squared equals C squared. That means 16 plus 16 makes C squared. That means 32 makes C squared, which means to get C on its own, C is the square root of 32. So C is approximately 5.66. I've had to round that, and I've shown you this by using the symbol. Okay, now if C is 5.66, remember I used C to represent EC. So that means I know that EC is equal to approximately 5.66. If I know what EC is, I can see on my diagram here, this is an isosceles triangle, ED is the same thing, so I'll just say ED is equal to EC, so ED must be equal to 5.66 as well. And now, remember what we're looking for here, we're trying to find the length from A across to D. I now know that ED is about 5.66 and A to E is 3, so if I add that together, AD is AE plus ED, which is 3 plus 5.66, that's about 8.66. And remember, I've rounded my answer way back here. So this has always been a rounded answer that I've been working with. So I'm not going to say it's exactly 8.66, but it's approximately 8.66 to 3 significant figures.